right, everybody, it is time to look at the topic 8 review. This one might be kind of a long video because this was a pretty long review and there's a lot of detail in it that I want to cover. So make sure that you are skipping around to the ones you really need, so you probably don't have to listen to my voice this whole time. But I'll go through and explain everything the best that I can. Starting with number 2 here, the ratio of the length of the leg adjacent to an acute angle in a right triangle. And the length of the hypotenuse is adjacent over hypotenuse. That's the cosine of the angle. Number 3, the blank gives a relationship between the sine of each angle in a triangle and the length of the side opposite to the angle. That would be the law of sines. Number 4, the angle formed by a horizontal line and a line of sight to an object above the line. That's going to be the angle of elevation. And 5, a blank is a set of 3 non-zero whole numbers that satisfies the equation a squared plus b squared equals c squared. We didn't necessarily talk about what this is called, but when we have 3 whole numbers that make up the Pythagorean theorem, and they're all whole numbers, none of them are fractions, that's called a Pythagorean triple. All right, so let's move on here. From lessons 8.1 and 8.2, number 6, to find BC, we can just use the Pythagorean theorem. So 5 squared plus x squared equals 8 squared. That's going to be 25 plus x squared equals 64. Subtract 25 from each side and get x squared equals 39. There's no way to simplify when we take the square root of that, so we just get x equals the square root of 39. And I can write that on this line, square root of 39. Number 7, the cosine of b. Now remember, the cosine means we don't want the angle measure of b. We want the cosine. So if we shrink ourselves down and we stand on angle b, cosine is opposite over hypotenuse. It's a fraction. Cosine is adjacent over hypotenuse. So square root of 39 over hypotenuse 8. That's all we need to write for number 7 is the square root of 39, that's the adjacent side, over the opposite, or over the hypotenuse of 8. And that's all we need. Number 8, the measure of angle A. To find the measure of angle A, we're going to, walk our shrink selves over to angle A. And we can use any of these values in a trigonometric ratio. I'm going to use 5 and 8 because those were the ones that were given to me. If I'm standing on A, 5 is the adjacent and 8 is the hypotenuse. Adjacent over hypotenuse is cosine. So the cosine of angle A is equal to 5 over 8. Then in order to get rid of cosine, I have to take the inverse cosine of both sides. So A is equal to the inverse cosine of 5/8. The inverse cosine of 5/8 is approximately, to the nearest tenth, 51.3 degrees. Number 9, Inez has 16 feet of rope to stake out the front part of her tent. Does she have enough rope? And explain. So the ropes are sort of on the outside, and then this middle triangle is the tent. It's got a height of 5 feet. Each one of these can be split into a right triangle. There's our right angle, and it's got a base angle of 40 degrees. So if I'm standing on the 40 degrees, and I want to know how long the rope is, I think, okay, I know the opposite, looking for the hypotenuse, going to use sine. So the sine of 40 is equal to opposite 5 over hypotenuse x, I don't know how much. And then I'm going to multiply both sides by multiply both sides by x. So I have x sine of 40 equals 5. But I don't want x sine of 40. I want x on its own. So I'm going to divide both sides by the sine of 40, get x equals 5 divided by the sine of 40. And by doing that, I find out that x is equal to 7.78. So this rope is 7.78 feet on one side, and since the triangle on the other side is congruent, that's 7.78 feet as well. And if I do 7.78 times 2, I get 15.56. Since she has 16 feet of rope, she has enough. Number 10, what additional information do you need to find YZ? So we want to find a second side of this right triangle. There are multiple ways we can do this. One way would be with the Pythagorean theorem. So if we wanted to use the Pythagorean theorem and find YZ, we would just need to know the other side of this triangle. If we knew 24 and the hypotenuse, we could use the Pythagorean theorem to find the third side. So either side xy to use the Pythagorean theorem, or we could use trigonometry. And if we used trigonometry, we would need to know one of these two angles so that we could stand on those angles and use an opposite over hypotenuse if we're standing on x, opposite over adjacent. Or if we're standing on y, it would still be opposite over adjacent. So we would be using tangent. So, or if we knew angle x or angle y, Pythagorean theorem, or angle x or angle y to use tangent. So multiple ways to do that problem. Numbers 11 and 12. 11, we're finding the measure of angle T. 12, we're finding RT. So we have an angle opposite side pair. We don't have a right triangle, but we have an angle opposite side pair, so we can use the law of sines. Number 11, we can say that the sine of 68 over the opposite side, 6.1, is equal to the sine of the angle we don't know, T, over the opposite side, 3.8. Cross multiply, that gives us 3.8 sine of 68 is equal to 6.1 sine of T. Divide both sides by 6.1. We'll get 3.8 sine of 68 over 6.1 equals the sine of T. But of course, I don't want the sine of T. I want the just angle T. So I'm going to take the inverse sine of both sides. So the inverse sine of 3.8 sine of 68 over 6.1 is going to be angle T. Put that in a calculator and you get 35.3 degrees. So T is 35.3 degrees. The next thing we want to do is we want to find RT. So in order to find RT, we're going to have to find the third angle, angle S, of our triangle. We can do that by doing 180 minus 35.3 minus 68, and we find that that is 76.7 degrees. So we'll use the law of sines again with the same angle opposite side pair that we know. The sine of 68 over 6.1 is equal to the sine of 76.7, the other angle, and its opposite side, x. We don't know that one, right? That's what we're looking for. Cross multiply. 6.1 sine of 76.7 is equal to the sine of 68 times x. But again, the sine of 68 is just a decimal, so I can divide both sides by the sine of 68 and do 6.1 sine of 76.7 over the sine of 68 equals x. Put that into my calculator, and I find that x is equal to 6.4. Number 13 and 14, law of cosines problems. Find each measure to the nearest tenth. So for JK, that's this side length right here. That's the one opposite of the angle we know, and we know the two other sides. So if we're looking for this, we'll call that our unknown, and we'll start with it since we know the opposite angle. we'll say x squared is equal to 21 squared plus 10 squared minus 2 times 21 times 10 cosine of 124. Then we'll put all of that into a calculator all at once and find out that x squared is equal to 775.86 or thereabouts. Take the square root of both sides, and we'll find that x equals 27.9. So that's JK, which is 27.9. Then, number 14, here I'll put numbers here. Here's 13, here's 14. For number 14, I can use the information that I already just found. So if I'm looking for angle J, I can now use the angle side pair that I already just made, the 124 and the opposite side 27.9, and I can use the law of sines instead, which is easier. So I'll say the sine of the angle 124 over the opposite side 27.9 is equal to the sine of the angle I don't know, angle J, over its opposite side of 10. We will cross multiply, so I've got 10 sine of 124, and I would get 10 sine of 124 equals 27.9 sine of J. So I'm just going to go ahead and divide both sides by 27.9 in the same step. So the other side is just the sine of J. That's just because it's a step that I can save myself in my work. I know that this is what the fraction is going to look like after I cross multiply and divide. I don't want the sine of J, I just want J. So I'm going to take the inverse sine of both sides. So the inverse sine of 10 sine of 124 over 27.9, it's equal to J. And when I put that into my calculator, I find that J is equal to 17.3 degrees. Let's keep going. Number 15, how wide is the gate shown? So this gate is made up, of course, of some triangular points, and we can figure out how wide each of those triangular points is. We see that this is an isosceles triangle. We also see that it has enough information in it that we can use the law of cosines to find the opposite side. That's probably the easiest way to do this. Once we find the width of one spike, we can multiply that together. So we'll start with the opposite side. X squared equals 4 squared plus 4 squared minus 2 times 4 times 4 cosine of 52 degrees. Plug all that into your calculator and you find that x squared equals 12.298. I'm just leaving a lot of decimals while I work on the problem. Take the square root of that and you get x equals 3.5. So the width of each of these fence posts is 3.5 inches. There are 8 fence posts in this picture. So 3.5 times 8 gives us 28 inches. The next one, number 16, skip it. It's too involved for us and it doesn't help us with the test at all. So we're just going to skip number 16. Number 17, find the area of each triangle. So in number 17, to find the area of this triangle, we talked about a few different ways to do this, and we could, using the law of cosines, find the opposite side length, and then we could find an angle in here after that using the law of cosines. But another way to do this, instead of using the law of cosines twice, is to remember that you can find the area of an obtuse triangle by artificially lengthening one of the sides that you already have and drawing the height down to that side. That works as well. And that height, of course, is going to make a right angle with the base. So if I found 18 times this amount divided by 2, that would give me my answer. So let's make that right triangle a little bit bigger and see what I know about it. That is not a right triangle. Close enough. Okay. So I know that the hypotenuse is 8 because that's the length of the side. And I know that this angle on the inside is 113, which means that the linear pair of 113 is the angle of the corner of this triangle here. That's 67. And I'm trying to find the height because I want to find the height of the whole triangle. So I'm trying to find x. So if I know the angle of 67, x is opposite of that angle and 8 is the hypotenuse. So the sine of 67 is equal to x over the hypotenuse 8. So 8 sine of 67 is equal to x. I can figure out what that is. That's 7.36 is equal to x. So in this case, the height of that triangle is 7.36, same as the height of the entire obtuse triangle. And I can find the area of the triangle by doing the base of 18. Remember, I stop the base right here. I don't keep going. So the base of 18 times the height of 7.36 over 2. And that's going to give us a total area of 66.3 meters squared. Number 18, in this case, I only have 3 sides, so I am going to need to use the law of cosines to find one of the angles. And since this is an obtuse triangle, it's easiest for me to just draw a height into the triangle about right there, which means I'm going to find either the angle in this corner or the angle in this corner. I'm going to choose to find the angle here that is opposite of the 6 centimeter side. And using the law of cosines, that means I'm going to put the 6 centimeters, the opposite side, first. So 6 squared equals the other 2 sides, 12 squared plus 14 squared minus 2 times 12 times 14, cosine of the angle I don't know, I'll call that x. And then I'll solve this. So 6 squared is 36. 12 squared plus 14 squared equals 340. Minus 2 times 12 times 14 is 336. Cosine of x. Next, I'll subtract 340 from both sides. That gives me 304. Actually, it gives me negative 304 is equal to negative 336 cosine of x. Divide both sides by negative 336. So that gives us positive 304 over 336 is equal to the cosine of x. Take the inverse cosine of both sides. 304 over 336 equals x. And we find out in our calculators that that means x is equal to 25.2. So that angle measure is equal to 25.2. I'm going to move my work over here a little bit. So I've got more workspace. There we go. So the other thing that I need to do here, once I find that angle, is I need to find the height of the triangle, because I'm going to do base times height. So I say if I stand on this angle I just found, looking for the opposite, and I have the hypotenuse, so I'm going to use the sine. So the sine of 25.2 is equal to the opposite x over the hypotenuse of 12. Multiply both sides by 12, so 12 sine of 25.2 is equal to x. That's going to give us 5.19 equals x, something like that. If you're a little off, that's okay. So actually it's 5.11. That's the problem. I couldn't read my own writing. 5.11 equals x. Then all I need to do is do my base of 14 times the height of 5.11 over 2. And I find that my triangle has an area of 35.77 centimeters squared. Number 19 is a little weird because we've never seen a problem like this before where we have 2 angle measures and a third side. But what we have to remember is, hey, if I have 2 angle measures, I can definitely find the third angle measure. So I can do 180 minus 35 minus 65, and I get 80. And we say, okay, what do we need to know in order to find the answer to this question? We're going to need to know the length of the height of my triangle. And I know that the base is 19. I need to find the height. in order to do that, I need to know some information about the right triangle that I create over here. 19 is the entire base, so I need another piece of information. I need to know this side length of the triangle before I can find the height of the triangle. Lucky for me, I can find this side of the big triangle using law of sines because I have an angle opposite side pair, and I also have the angle that is opposite of this side. So I can say the sine of 80 over 19 is equal to the sine of 65, the other angle I'm looking at, over its opposite side, x. Cross multiply, I get 19 sine of 65 equals x sine 80. But I'm going to go ahead and divide both sides by the sine of 80 because I know I'm going to need to anyway to get x on its own. So there's my fraction. And I can put that in my calculator and find that 17.49 is equal to x. So this missing side of the triangle is 17.49. Once I know that, I can use the sine opposite over hypotenuse if I'm standing on the 35 to find the height of my triangle. So sine of 35 equals x, my height, over 17.49, my hypotenuse, multiply 17.49 times the sine of 35 equals x. And then put that in my calculator, I get 10.03 equals x. So that's the height of the triangle. Then I'll take the base of my triangle, 19, times the height, 10.03 over 2. And I'll find that my area is 95.28 feet squared. So lots of different ways to do problems that are similar to this. And actually, we've got one more on the next page. It's a long worksheet, but that's okay. It's going to help us get really good at what we need to know in order to do this test. So this last one is another weird one where I know a few things, but I don't know all the things. I know 10 and I know 15. I don't know the third side of this triangle, and I know a 32-degree angle lives right here. So let's see, how can I do this one? I could find the length of the third side of this triangle, and I could do that a few different ways, and I'll show you one way. This was the first way that came to me. You might find it a different way. I said, I'm going to find the height first, because I know I have enough information to use this right triangle over here to find the height. And then once I found the height, I was able to find other things after that. So I said, okay, here's the height. I've got 32 that I'm standing on. Opposite over hypotenuse is sine. So the sine of 32 equals x over 15. Multiply both sides by 15, so 15 sine of 32 equals x. Put that in the calculator, and 7.95 equals x. So the height of this triangle is 7.95. But then I need the base. I can get part of this base right here by using trigonometry with this triangle on the right. Instead of using sine, opposite over hypotenuse, I can use cosine, adjacent over hypotenuse. I can say the cosine of 32 equals adjacent x over hypotenuse 15. Multiply both sides by 15. And put that in my calculator. Get 12.72 equals, in this case, x is the right-hand side of the base of the triangle. Whoops, 12.72. Then I need to get the left-hand side of the base. And this is where you might go, well, what do I do? But notice, think smarter, not harder. I know two sides of this right triangle. I'm just trying to find the third side, the other part of the base. I'm going to use the Pythagorean theorem. X squared plus 7.95 squared equals the hypotenuse of 10 squared. So x squared plus 63.2 equals 100. X equals 36.8, sorry, x squared take the square root, and x equals 6.1. So the other piece of this is 6.1. So to find the area of the triangle, I take the base, which is 2 pieces, 6.1 plus 12.72. Multiply that by the height of 7.95. Oops. 7.95. Divide by 2. And I find that the height is 74.8. Or sorry, the area is 74.8. Number 21, a hiker whose eyes are 5.5 feet above the ground. That's going to tell us something. That tells us this piece right here is 5.5 feet, which is part of the height of the right triangle there. They look down at a kayaker on the far side of the river below. How could we find the approximate width of the river? So we are going to do regular right triangle trigonometry here because we have a right angle. We have a 74-degree angle of depression right here. But we know, because of alternate interior angles, that this 74 and this angle are congruent. So the angle down here by the kayaker is also 74 degrees. And if I stand on that angle, I know the length of the opposite side. I'm looking for the length of the adjacent side, the width of the river. That's tangent as opposite over adjacent. So the tangent of 74 is equal to the opposite side. The opposite side is 58 plus 5.5. So that's 63.5 over adjacent, which is x. If I multiply both sides by x, I get x tangent 74 equals 63.5. But then I'm going to divide both sides by the tangent of 74 so that I get x on its own. So 63.5 divided by the tangent of 74, which of course is just a number. I can do that. And I put that in my calculator. X is equal to 18.2 feet. So the width of the river is approximately 18.2 feet. Number 22, what is QS? This goes all the way back to knowing about the special right triangles, because this has a 30, 60, 90 right triangle and a 45, 45, 90 right triangle in it. If I have a 30, 60, 90 right triangle and I have a 10 right here, that means that 10 is the side length of the triangle that we would usually call x root 3. It's the longer leg of this 30, 60, 90 triangle. And if I tell myself that 10 is the side we usually call x root 3, then I can go from here and I can divide both sides by the square root of 3. Oops. Why? Divide by the square root of 3, so I get 10 over root 3 is equal to x. But I can't have 10 over root 3. I need to rationalize my denominator. So I'm going to multiply it by root 3 over root 3. And that's going to give me 10 root 3 over 3 equals x. So the short side of my triangle is 10 root 3 over 3. It's looking for QS. So then I say, all right, well, I need to find TS. Since this is a right triangle, 45, 45, 90 right triangle, the legs are the same length. It's isosceles. So TS is 10 root 3 over 3. Then I need to find QS. That's the question. So QS is just these two parts put together. It is 10 plus 10 root 3 over 3. Of course, we can get a good decimal for that as well. I'm going to leave it in exact answer form, but you could make this a decimal approximation of that value if you would like. Number 23, 24, and 25, find the unknown sides for each of these. I have two sides, which means I'm just going to go ahead and use the Pythagorean theorem. Say 9 squared plus the other leg squared is equal to 5 root 10 squared. I need to remind myself what 5 root 10 squared does. So I've got 81 plus x squared. Then I've got 5 squared, which is 25, times the square root of 10 squared, which is 10. 25 times 10 gives me 250 minus 81. We know how to solve the rest of the way. X squared equals 169, so x equals 13, the square root of that. Then the other example here, we've got 10 and 13 as the legs. Simple stuff, 10 squared plus 13 squared equals c squared. And then we will say 100 plus 169 equals c squared. So 269 equals c squared. Take the square root of both sides. Amazingly, there is no way to simplify the square root of 269. So we're just going to leave it under the radical like that and say the square root of 269 is c. A couple more on this page, finding the perimeter of each triangle, which means we need to find the other two sides. If I've got this triangle right here and I need to find the other two sides, I can first find the third angle very easily by subtraction. I find out that that's 70 degrees, and that gives me an angle opposite side pair. I can use that angle opposite side pair along with the law of sines to find the other two sides of this triangle. So I'll use the sine of 70 over 26, since I know that pair, is equal to the sine of one of the other angles, maybe 45, over the opposite side, x, which I don't know. Cross multiply, you get 26 sine of 45 over the sine of 70 equals x. Put that in your calculator, and you find out that you get you get 19.56. So the side opposite the 45-degree angle is 19.56. We'll do the same thing for the side opposite the 65-degree angle. We can say the sine of 70 over 26, so that same angle opposite side pair, equals the sine of 65 over the opposite side x. Cross multiply, 26 sine of 65 over sine of 70 equals x. And we find out that's 25.08. And then we can go ahead and add all three side lengths together. And when we add all three side lengths together, we've got 26 plus 25.08 plus 19.56. We want to round to the nearest tenth. That's going to give us 70.6. Another perimeter problem here with 26. To find the perimeter for this one, we can do the same process. So if we do the same process, the third angle is 70 degrees again. We'll use the angle side pair we know to solve for both sides. So the sine of 72 over 19 is equal to the sine of 70 over x. And also, the sine of 72 over 19 is equal to the sine of 38 over its opposite side, x. So we'll cross multiply in each case. 19 sine of 70 over the sine of 72 equals x, which means that that side opposite of the 72-degree angle, opposite of the 30, I'm talking weird, opposite of the 70-degree angle is 18.77. We can do the same thing for the other law of sines. So we can cross multiply. So 19 sine of 38 over the sine of 72. And that's equal to x. And when we find that in our calculator, we find that the side opposite the 38-degree angle is going to be 12.3. So we'll write that here. Then we can add our side lengths together. We've got 12.3 plus 19 plus 18.77. Rounded to the nearest tenth is 50.1. 2 more problems. Both of these we're just finding x. So in the first problem, we have 2 sides, and we have to find the third side. We know the angle in between the 2 sides. We don't know an angle opposite side pair, so we're using law of cosines. Law of cosines will start with the side opposite of the angle we know, so that's x. So we've got x squared equals 6 squared plus 9 squared minus 2 times 6 times 9 cosine of the angle we know, 25. Luckily, we can put that whole thing in the calculator. We get x squared equals 19.11. Take the square root of both sides, and we get x equals 4.37. To the nearest tenth, that rounds to x equals 4.4. And last but not least is we've got this problem where we have all 3 sides. We're looking for the angle. We're using the law of cosines because we don't have an angle opposite side pair here. And we'll use the side opposite of the angle we're looking for to start. So 9 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 cosine of the angle we don't know, angle x. So that gives us 81. 6 squared plus 8 squared is 100. 2 times 6 times 8 is 96. Cosine of x. Subtract 100 from each side. Negative 19 equals negative 96 cosine of x. Divide both sides by negative 96. That gives us a positive 19 over 96 equals the cosine of x. And of course, I don't want the cosine of x. I want x on its own. So I'll take the inverse cosine of 19 over 96 to get x. And when I put that into the calculator, I find that that is 78.6 degrees. And that's everything for this review. There's a lot of stuff on there, but some of it is repetitive, the same type of problem in different ways. If you've got any questions for me, let me know and I can help you out the best I can. Have a wonderful day. Hopefully you're able to do this well.